In this video, I've given a somewhat challenging limit question. This is the limit as x goes to 0 of 1 divided by x times the square root of x plus 1 all minus 1 over x. What we're going to do in this video is do a series of different algebraic manipulations to take this gnarly and annoying looking thing and make it a lot simpler and be able to compute this limit. Now, before we get into it, I'm going to do a sort of naive approach to see whether I can sort of guess the answer. I'm going to focus perhaps first on taking the limit just as we go from the right. And I note that we've got these two different factors. It's a difference of two things. And if I look at just the first one, then, well, this is 1 divided by 0, a little bit bigger than 0 from the right, and 1 divided by 0 is going to be positive infinity. So if I take a sort of a naive approach, just sort of guessing what I think things are going to look like, it looks like a 1 divided by 0 on the left, and again a minus 1 divided by 0 on the right. Or in other words, it sort of looks like an infinity minus an infinity. Now the point here isn't that any of this is mathematically rigorous, it's to suggest that we don't have an answer. Infinity minus infinity, we don't really know what it is. It depends exactly on how fast these things grow. So we can't just sort of use this naive approach. We can't just plug numbers in. We're going to have to do some formal algebra to make it nicer for us. So let's do that now. When I'm trying to solve something algebraically, what I'm stuck with is trying to figure out what algebraic tricks should I use. I notice I've got some square roots here. I've got a difference of some fractions. There's maybe a bunch of different things I could do. I could even take this value of x and move it onto the inside. But the point is I have to figure out what is a useful algebraic trick to do. But what the real goal is to figure out a useful algebraic trick. And what comes to my mind, what my first guess is that because it really is a difference of fractions, that we should probably think to find a lowest common denominator first. So I don't know if this is going to work out, but let's find a lowest common denominator and see whether or not this is useful. So what I'm going to do is I'm going to say that this is equal to, and I repeat that it's the limit as x goes to 0, and I'm not doing the naive approach now, so I'll keep it from both sides. And I'm going to do a cross multiplication here to find a lowest common denominator. So it's an x on the top, and then I'm going to subtract off x, the square root of x plus 1. And then this is all divided out by the product here. There's an x and there's another x, so they're going to combine when I multiply them to be an x squared, square root of x plus 1. Okay, this is not bad. It's actually relatively decent, and in fact, if I wanted to, I could go one maybe slightly further step and cancel the x here, and the 2 there, and I'll rewrite this just to keep it a little bit simpler as the limit as x goes to 0 of 1 minus the square root of x plus 1, all divided out by a single copy of x, the square root of x plus 1. Okay, so I've done some algebraic manipulations. Am I done? Can I just plug in the value of x equal to 0 now? Am I sufficiently far along? Well, I don't think so. Indeed, if we look at what we have and we did another naive substitution, so again, caution, we're doing the naive approach here, this kind of looks like, if I just plugged in 0, it looks like a 1 minus 1 on the top and divided by 0 on the bottom, or in other words, it looks like a 0 divided by 0, and this is another indeterminate form. I don't know how to deal with 0 over 0, so I have to keep on going. I have to keep up with my algebra. So let's do a few more steps here and see what we're able to get. All right, so what algebra can I do next? Notice how I have this square root on the top. Getting rid of the extra stuff, this gives me the space to say that when I've got the square root, the alarm bell that you should have is to take the radical conjugate. And so what I'm going to do is I'm going to multiply the top by 1 plus the square root of x plus 1. And I'm going to multiply the bottom by 1 plus the square root of x plus 1. And of course, I'm allowed to multiply by funky versions of 1. Multiplying by 1 doesn't do anything. And this, well, it looks strange, is the funky version of 1, so it's perfectly justified. All right, so let's do this multiplication and see what we get. I'm going to say that this is equal to the limit as x goes to 0, as always, keep that out the front. Then the way the multiplication here works is I'm going to have a 1 squared, but just 1. I'm going to be subtracting off an x plus 1, and then the cross terms are going to cancel each other. And then this is all going to be divided out by x square root of x plus 1, 1 plus the square root of x plus 1, which is Kind of a mess, but no worries, we can deal with that for sure. All right, next up. I've got a 1 and a subtraction of 1 on the top here, so I can get rid of those. And then I think we can do multiple steps at once here. I'm going to note that we have a x on the top, and then I'm going to have down on the bottom here, we have an x there. So I can get rid of both of those two components, and I'm going to put it together and give me the limit as x goes to 0 of a minus 1, don't forget the minus 1 that's left up here, minus 1 divided out by the square root of x plus 1. So that was me multiplying these terms. And then if I multiply the two versions of square root x plus 1, I get square root x plus 1 squared. And so I'm going to be adding x plus 1. All right, so that was relatively decent. Now let's see whether I can do the naive approach and just sub stuff in. Is it justified here? Well, if I plug in 0, I get minus 1 on the top. And on the bottom, I'm going to have a 1 plus 1. Finally, I have something finite on the bottom, and so I'm quite able to come along here and say that this is just going to be equal to minus 1 divided by, and I'm going to write all the steps here, the square root of 0 plus 1 plus 0 plus 1. And I've noticed that I've gotten rid of the limit here because I'm now evaluating the limit, so I don't repeat the limit sign down. In other words, minus 1/2. And that is my final answer. So in other words, what we effectively did was we started with our limit, we did a lowest common denominator, and then we applied the radical conjugate, doing a bunch of simplification as we've gone along, and that gives us to this nice clean answer, minus 1/2. I also want to point out that whenever you're doing algebra like this, we don't know ahead of time exactly what the right algebraic steps are going to be used. We might be able to anticipate it. We might be able to anticipate, for example, that a difference of fractions is probably going to involve a lowest common denominator, that one of these 1 minus a square root of stuff is probably going to involve multiplying by a conjugate. These are likely steps, but this is not always the right case. And often in mathematics, you'll go along doing some algebraic steps, and if it's not working out nicely, step back, think about some different algebraic steps you could do and execute those instead.